Hello and welcome to SudoKanard. We're here to solve this XY differences Sudoku that I created for the recent WPF Sudoku Grand Prix. It's the first time that this variant has appeared on Sudoku Grand Prix, but not on the channel because I already covered quite a number of those puzzles by my good friend Glum Hippo, who invented the variant. And I'm very glad I could have this featured on the Grand Prix. So, what's the special rule? You can see those special symbols, those diamond symbols, those square symbols, which mean that the difference between those two digits here that are connected vertically by a symbol is the value of this digit, the first in the column. And likewise, when you have a symbol that connects two cells horizontally, the difference of the two digits is the first digit on the row. In this case, this is 1, and in this case, it is 3. And that's not all. All possible symbols are given, which means that in this case, between those two cells, the difference is not 3. It's not this. Well, we already knew that the difference couldn't be 3 because 5 is already here. But in many instances, this will be very useful. All right, so in this column, a difference of 3, there are two families, the family 258, the family 369, and the family 147. So this can only be 147, 369 are not available. That's 4 in the middle, surrounded by 1 and 7. And now 6 and 9 must go there. But a 6 here would force a symbol between those two cells, because that difference is 3, so that's the 9, that's the 6, thanks to the negative rule. Here, those must be 3 consecutive digits. They can't be with 2 or 3, because 2 and 3 would be accompanied with 4 or 1. So 2 and 3 are in those two cells, and by the same logic as here, 2 does not belong in this cell because we would need a symbol between them. So that's the 3, that's the 2, and those are 7, 7, 8, 9, with 7 in the middle. All right, so that's the beginning. Some logic that often appears in those kind of puzzles is that 9 is never the difference between two digits. So on the first column and on the first row, 9 will have to go into cells that are not, well, what I mean is that 9 on this column goes somewhere where it's not accompanied by a symbol on this row. So this would be a possible place for 9. This would be a possible place for 9. All other rows have, well, actually, no, this would be a possible place for 9. This would not. But actually, this wouldn't work because 9 here would mean that the difference is 8. So 8 would go there. And this would be 11 or minus 5. So that's not a possibility. And similarly, so we have symbols here. We don't have a symbol here, so 9 is possible. We have symbols here, here. We don't have symbols here, but 9 is already there. So on this row, 9 can only be there. So that's not a 9. And on this column, 9 can only be there. So this is some interesting logic. And 9 here turns this into 7, and that's the 9. Now this digit has a part to play because it's the difference between those and between those. And there are still 4 values for this and 4 values for that. So let's just ponder. The values here are 2, 5, 6, 8. The values here are 4, 5, 6, 8. And the difference here and there must be the same. So let's just ponder. The differences here are 3, 4, 5, 7. The differences here are 1, 2, 5, and 3. We can see that only 5 is common to both of them. So the difference here is 5, and this is 6, this is 8. So now difference of 5, which will mean 2, 7 or 3, 8. And that's kind of interesting. So 2, 7, 3, 8, because the difference here must be the difference there. And a difference of 7 or 8 will never work here. And a difference of 2 here would mean that this is 2 or 6, but 6 is not possible, and 2 is not possible if I put a 2 in here. So that has to be the 3, and that's 8. And this is now 1 or 7. So this will probably be disambiguated by this digit, but that's a 7. And this is, those are not candidates. Those were the prospective sums for those. This column still needs 2, 4, 7. And actually, those can, yes, so I will remove 7 from here. So 7 is there. But if 7 comes with a 2, then I need a symbol. And this is not true because, well, there's no symbol. By this I mean the difference can't be 5 because there's no symbol. So 2 is not in here. 2 is down there. Which is interesting because now we have a difference of 2 between those digits where they can still be 1, 3, 3, 5, 4, 6. So that's not so interesting. All right, so now I'm thinking I could do the same logic here as here. Those could still be 1, 6 or 2, 7. But let's have a look at this and that. So 6 and 7 are much too big for this because with 6 or 7, they just don't work because of 2 and 3 here. But they would be much too big for a double symbol. So that's 1 or 2, but 1 would turn this into an 8, which is not available, so that's actually a 2, and that's a 7. This is now 7, this is 5. This could still be 1, 3, 4, 6, or 6, 8, so I won't pencil mark that. But this 7 tells us that this is 1, and this 2 tells us that this is 3. So this is not 1 and 3. This has to be with 2 even digits, 4, 6, or 6, 8. This is not 4. We still need a 1 in the column. And actually, this 8 tells us that the difference here is 8, and the only option is 1 and 9. There's a 9 here, so 1, 9. Oh, and the 7, 1 is disambiguated by this, finally. 2 does not come with a 4 next to it because we will need a symbol. So 4 is here, this is 6, this is 8. And this is 7, this is 4. 4 is the difference here, so that's a 5. The first row still needs 1, 4, and 6. And actually 4 can only be here. So those are 1 and 6. Now, what about this? 1 would turn this into a 4, 6 would turn this into a 9. Both still look possible. But 6 here would turn this into a 3, and that's not possible. So that's the 1, that's the 6. So that this is 8, and this is 9. 8 on this row must be here. This is a 4, 5 pair, but with a 2 here, 4 here would impose a symbol. That's a 6. Here I need 4 and 5. Oh, 7 goes there. That's the 2, that's the 6, just by the rules of Sudoku. So here, difference of 6, it can only be 2 and 8, so that's 2 here and 8 there. Here I need 1 and 3. Here I need 3 and 6, there's a 6 here. Here I need 5 and 9, so that's 5 here, 9 there. 5 here, 4 there, and the rest should be plain Sudoku, I think. Oh, actually, this 4 tells us that this is 5, but this 5 could have told us as much. This is 8, here I need 2, 3, and 9, so that's 9 here, 2 and 3, oops, 2 and 3 there. Here I need 2, 4, and 5, 2, 5, and 7, sorry, so that's 2 and 5 here and 7 there, 2 here, 5 there. Here I need 1 and 4, so that's 4, that's 1. Here I need 2 and 6, so that's 6, that's 2, that's 6. 2, 3, 3 here, and 4 there, and that's it. So this XY difference in Sudoku was really not that hard if you know where to look, and that's where the numerous practice puzzles by Graham Hippo were a precious thing. Thanks for watching this video. See you soon on SudoKanard.